one, the area will be increased. So this is the concept. So this formula is only to determine whether the strain gauge will happen plus or minus. Okay, so for this one, you got it R minus with theta R. Okay, alright. Okay, so far so good. Any question? Rahul Hassan, any question? No? Where are you right now, Rahul?
No.
No. Yeah. Nurul Amirah dekat mana? Rumah.
Dekat rumah sebelah tepi jalan.
Sebelah tepi jalan. Kenapa? Dia buat apa?
Apa sih?
Apa dekat rumah sebelah tepi jalan?
Rumah saya sebelah tepi jalan pun bising. Sorry.
Oh, okey okey. Ingat ke tengah order roti canai. Okay. Alright.
Sorry for
So this
having internet issues. I'm in Bangladesh, doctor.
sorry, I cannot get what you like. Rahul have left meeting now. Okay, done. Right. Okay. Alright. This is
Rahul, having internet issues today, and I'm in Bangladesh.
Bangladesh. So what's time right now at Bangladesh? What time? Okay, this is the strain gauge characteristic. So how you apply the strain gauge, right, on a certain object that are you going to measure? Okay, this one lah. Okay, you can measure the strain gauge at the top one and then at the bottom one. Okay, this is the experiment lah. Alright, so when you buy a strain gauge, alright, you will got it one parameter, we call it the gauge factor. Okay, so the gauge factor is have their own relationship between the what we call it the resistance and also the strain. Alright, so the strain of your electrical strain gauge. So the formula will give you the delta R over R and divided with the strain. Okay, right. So gauge factor is determines delta R over R and over we call it strain. Okay, done. Right. Okay, so there are different material lah. Okay, about the strain gauge. Okay, next. So example 15.1. Okay. Alright, this one is quite simple, I think. Example 15.1. Alright. Right now we have learned 1, 2, 3, 4. 4 formula there. Example 15.1, a strain gauge with resistance R equal to 120 ohm and gauge factor equal to 2. Okay, so you just draw the strain gauge. So this one your strain gauge. So he got it. The R is equal to 120 ohm. Okay, and then he also have the gauge factor equal to 2. Okay, the gauge is applied to a material with the modulus Young E equal to 200 times with 10 power of 6. So that's mean it's like you apply, this is your material, for example, and then you apply your strain gauge here. Okay, it's something like that. Okay, all right. And the maximum stress, okay, equal to 50 Newton per meter, and then maybe you apply what we call it, the compress, right? You apply the stress here is equal to 50 Newton. Find the maximum resistance change for the gauge. So maximum resistance change which means delta R. So he asks you to find the delta R here. Okay, so it's quite simple. So the formula that we have right now, okay, GF, right? This one, you can use this one, okay, and you can use the formula 3 and 4 there. So GF delta R over R divided with strain, okay, where the relationship the strain is give you the modulus Young and strain. Okay, here. All right. And then the stress that you apply is 50. The strain, the modulus Young is 200 times 10 power of 6. And then you have the strain here. So strain, where you got it, is equal to 2.5 and 10 power of minus 7. Okay, here. Now you already got a strain. Then we can apply the gauge factor there to delta R over R is the initial value 120 ohm. 120 ohm divided with the strain 2.5 then 10 power of minus 7 2. Then we can get our delta R here. Okay, so that means you got it is 6.5 then 10 power of minus 5 ohm. Okay, all right. So the initial value for the strain gauge, right, that apply on this material is about 120 ohm. And then you apply the stress, right? So whether you apply it, we call it what we call it. We apply as like a compress or we stretching it. So it depending, right? But the result of the resistance chain will give you the same value. Okay. So this one delta R equal to 6.5 then 10 power minus 5. Okay. Alright. So what this means, the initial value R is depending plus minus with delta R here. Okay. So far, do you have any question? Simple. It's quite simple. Ada apa-apa soalan? No? No? No. Okay. Alright. Stay sleepy. Ngantuk lagi? Belum? Dah breakfast? Sudah? Okay. Alright. Next. Okay. We already know about 1, 2, 3, 4 formula there. So let's look about the load cell. Load cell is, that means you apply okay. Belum tidur lagi. Wow, Herman Chia buat apa? Main game lah tu. Tak ada kerja lain dah. Dah tengok bola. Guys, who live around Johor Bahru? I just want to know kat mana apa sekatan polis whether going to what we call it Eco World, is it there any police there? No, you know. Okay, never mind. Just leave it. Okay. Alright. So now for this topic is about the load cell. Load cell that means you going to develop sensor, alright. For example, it's not a sensor. We call it an instrument. Yeah, and the instrument that combine between your strain gauge here is strain gauge and also your object here. Okay, so this one you use to measure the load. Okay, so for example is the weight scale here, right? This one. So inside this one have the object and then have the strain gauge here. Okay, so now what we going to know about it, this one, the relationship is quite simple. So for example, you apply the force, right? P. Okay, so the input will be P and then the output will be delta R over ratio R here. Okay, so for example, apply 50 Newton. So what is the value of delta R and R? So we can know about it. So we're going to find the relationship for this load cell. So this, you need to use the formula stress F over A, and also the formula of strain. Okay, and then you also use the formula for gauge factor. You combine all together, and then you got it. The formula for this load cell is equal to GF over EAB you time with P. So your P now is the force that you apply, the weight that you apply, right? So this one, right? And then GF is already fixed. When you buy the strain gauge, it has their own GF. And then the modulus Young of this material. Of course, when you want to buy any material, you need to know what is the modulus Young of this one. Okay, and AB, that's mean the area. Okay, this area is depending on your material or object that you're going to use for in order to develop an instrument. Okay, so if you use the square root, so the area will be A times B. So A, what is it? This one is A. Okay, you time with B here. Okay, because we're going to get the area for this one, at this one. Okay, and if you apply at the rod, right, so the area will be in term of this one, right, so pi r squared. Okay, what else? If you have the triangle, sorry, it's not on our topic. Okay, I don't know how to do that. Okay, all right, so this one we give you the block diagram for here is GF here divided with EAB. If you apply the square object, right? So formula number 5, delta R over R is equal to GF over EAB you time with B. Okay, so this one is the load cell. We call it a load cell. Okay, and you apply it. All right. Okay, done. So now is formula number 5. And then sometimes we can have the bending load cell. So bending load cell means that you will have some rigid one, this one, okay, and then you put your strain gauge, right, at, for example, like this one, you put it here, and then the force that apply at the end of this one, right, at the end of this one, so we call it is the bending load cell. Okay, so bending load cell is also have their own formula. Delta R over R is equal to sig x, and then you got it GF over with EAB squared you time with B. Okay, so how to get this formula? I think you can go through all this one step lah. Need to find the moment initial, distance, and so on. Okay, this one. Alright, 1, 2, 3, 4, 5, 6. So 5 and 6 is load cell. 6 is bending load cell. So how to get this formula? By combination between formula 1, 3, and 4. Okay, done. Alright, so let's look example 15.2. Figure below show a simple load cell. Okay, formula number 5, simple load cell, consisting an aluminum rod. Okay, okay, all right. Ignore first the word catheter and compensation strain gauge. The 120 ohm strain gauge and gauge factor is 2.13. All right. So you got it. Simple aluminum rod. Okay, like here, and then you apply some force right here is equal to some load to 5000 lb. Alright, so the modulus Young for this rod is equal to 6.89 10 power of 10. Alright, so what we will have here is we gather all the information first. So this is your strain gauge. Now your strain gauge have the R equal to 120 ohm and your gauge factor equal to 2.13, and then you apply your strain gauge to the rod. Okay, this is your rod. Okay, so now your rod have the R equal to 2.5 cm. This one equal to 0.025 meter. Correct or not? 0.25, right? 0.25 meter. Done. And then this rod have the modulus Young is 6.89 10 power of 10. Okay, done. Okay, so this one load cell. Okay, load cell. Next. So that means the load cell. So you got it, the formula for delta R over R is equal to GF over E AB times with the P. Okay, so AB, so you need to change. So this one, let's find the P first. So P you apply is 5000 lb. Then you need to convert it to Newton. The formula for Newton is divided with 0.2248. Then you got it is 22240 Newton. Okay, this one done. So AB you need to convert with pi r squared there. Now you got it, the formula delta R over R equal to your GF E pi r squared you time with 22240 Newton. Then you can find the delta R here. Alright, because already is that your GF, your strain gauge factor there, modulus Young of the rod there, pi r squared R is there, done. P, okay, done. R, the initial value for the resistor, done. Then you can get the delta R. Okay. Alright. Any question? Simple? Very simple, right? Okay. Strain gauge, quite interesting. Very simple. Okay. Right now is very simple lah. Okay. Don't know yet what happened in the exam, right? Okay, done. So the concept is like I mentioned you before, for the load cell, the block diagram for the load cell, GF over E for the, in this case lah, pi r squared, and then you will got it the ratio of delta R over R and this one P. So when you apply 240 Newton, you will got it, the answer is delta R over R something. Okay, alright. That's the formula. Okay, alright. Then the next one, the sig. Okay, the formula sig. Okay, alright. Normally we will combine your our strain gauge, right? Our strain gauge we combine it with the western bridge. Okay, so we don't try to measure the R, because the delta R will be give you very small ohm, right? Very small ohm. So it is quite difficult to measure it. So we will try to we will combine it with the Western bridge so that we can get the opioides offset. So it will give you the gain, right, for the offset. So how you do it? Right now you already quite familiar with the Western bridge. So this one, and this one, and this one. Okay, right. So this one delta V R1 R2. In this case R2 R3. Okay, this one is R4. What happened is in this one you apply with the strain gauge here. Okay, so this one we can put it in R4. All right, this is the strain gauge here. Okay, so what the relationship between this formula? Now what we got it is here is delta R over R, and this one delta V. So delta V over V is equal to delta R over R divided with 4. Okay. Alright. So if you want to find the delta R over R here, so we can find it, the delta R over R. Okay, delta V equal to delta R over R time with V over 4. So this one can be V over 4 here. Okay, simple. So the next formula will be this one. Number 7. The formula will be delta V over V equal to delta R over R divided with 4. Okay, so this is what when you apply the strain gauge. Okay. Right. So formula number 7. You apply your strain gauge on the Western bridge. Okay. V, that means the V in. Okay. However, when you apply your strain gauge like here, oh, I need to draw it again. Okay. Tin, 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 tin. Delta V, R1, R2, R3, and this one R4. Okay. For example, let's look this value. Okay, this value we choose. The initial value is 120 ohm, and to make sure that this the offset value equal to 0, so we choose all the same value: 120 ohm, 120 ohm, 120 ohm. So when R2 times R3 equal to R1 and R4, so we got your delta V equal to 0. Okay, done. However, when you apply your strain gauge on a certain object, right? So it will have some effect. We call it a temperature effect. So for example, so this is your object. Now you apply your strain gauge here. Strain gauge here. Okay. So for example, temperature at that time is 20 degree, and your strain gauge now is 120 ohm. Okay. Now, when there are changes in the temperature, for example, your temperature is 25 degree, so this one also will change 120 ohm. It will change maybe 130 ohm, for example. Okay. So how to solve this one, how to compensate this one is by applying another strain gauge. Okay, right. Let's say this is when you apply your force okay, P, okay, I put it P, symbol P, alright, and to make sure the value, alright, so, okay, before that, so when there are temperature change, 25 degree, so this value will also change 120, we change it to 130. That means your delta V is not null anymore. It's not balanced anymore. Alright. So the first one is you're going to start the measurement, but the temperature is changed. So how can you want to start the measurement? Because you cannot set the delta V equal to 0. So it's very difficult. So what we do right now, we apply another strain gauge, but at opposite direction. So why I apply at this direction? So remember, only the sensitive, this one the sensitive, and this one is not sensitive. Okay, alright. So that's mean when I apply it, okay. So maybe I put it here, another strain gauge, but at the difference, how to do that? Okay, at the difference direction. Okay. So with this one, we call it is R3. Okay, let's look again. So the initial value is 120 ohm. So this one is 120 ohm also. Okay. At the temperature is 20 degree. All right. Then the temperature change to 25 degree. So this strain gauge will also change to 130 degree. So this change to 130 degree. And also this strain gauge also change to 130 degree, 30 ohm, sorry, 130 ohm. So if you see that, you will get the delta V will remain 0, will remain none, will remain balanced. Okay? Did you get that concept? Dapat tak konsepnya? Okay. Okay. Do you have any question? Brain processing. Okay. What core that you use? Intel i7, i3. RAM tak cukup. Okay, that's why you need to upgrade your RAM and also your hard disk SSD. Doctor, why is delta V equal to 0? Yes, when you apply your strain gauge on the western bridge, okay, right? So you want to make sure your delta V equal to 0 so that you can make some measurement. Okay, if you don't make your delta V not equal to 0, yeah, you also can, but you need to minus with your voltage offset lah, delta V. For example, right now you make the measurement, so you will got it, your delta V at the measurement is 4 volt. So on the real one is 4 volt minus 2 volt. Okay, for example, your offset value. Right? So if you can maintain your offset value equal to 0, that means you don't need to minus. Okay, but in this case, we need a true strain gauge so that we can get it, the delta V is equal to 0. So whatever the temperature change, we can maintain the delta V equal to 0 before we make the measurement. Okay, boleh? Faham? Yes. Okay, good. So done. Alright. Okay. So if you look at this one, you only have two strain gauges. So first one, if you apply your force like this one, so this one we call it is active. This one we call it dummy. So dummy strain gauge is used for counter the temperature. Okay. This technology used in weight scale, yep, correctly. In the wet scale, you have the load cell and also bending load cell. Okay. All right. So when you apply this active, only one active, okay, only one strain gauge, we call it active. So this one we call it the half bridge. So this one is half bridge. Okay. All right. This one the theory lah on what I have mentioned before. Okay, so if you apply for the both, for example, top and bottom, so you have used all this bridge. So this one only half. So when you apply both, one more active, so we call it full bridge. Okay, all right. So let's look example 15.3. 15.3 is quite simple. Figure below show simple load cell, okay, with the aluminium rod 2.5 cm radius, a detector and compensation strain gauge. Yeah, is from example 15.2. Okay, determine the variation of delta V. Okay, delta V here. All right, you're going to find the delta V here. All right, for R1 equal to R2 equal to RD and give you the K factor and so on. All right. Okay, so this one is quite simple. What can you got it here is you already got it delta R over R from the formula number 6. Okay, so you got it 3.501 times 10 power of minus 4. Okay, so GF is already formula number 5 because this one is load cell. GF already there, give it to you. Modulus Young is already there. AB, so you need to change to pi r squared because the rod. And then the P you apply in Newton, 22240 Newton. Okay, then you got it the delta R over R here. And then you can find the delta V over V is give it to you 2, okay, and then delta R 3.51 times 10 power of minus 4 divided with 4, then you can get it delta V. Okay, all right. So when what we call it the load cell that apply, okay, I give you this for this one. So you got it your load cell, right? So this one P, and then this one the output will be delta R over R, and then this one will be delta V. That is the relationship. Okay, P, you've got a delta R over R, so formula number 5, GF over with E pi R squared, in this case for the rod, delta R over R, and this one will give you, what is it, V over 4, right? Okay, so V over 4, so you need to times with delta over R, then you can get it, delta V. So the input is 240 Newton. It will give you 3.501 times 10 power of minus 4. And then it will give you delta V 1.75 times 10 power of minus 4 volt. Okay. So you can see that. So when you apply the difference force, it will give you the different delta V. Okay. So from the load cell, you combine to Western bridge. Alright. Okay. Clear? Any question? Yeah. Clear. Okay, good. Alright. Then formula number 7 for the half bridge. So I'm normally like to put it delta V here is I put it is half. Okay. Right. So when you fully utilize the Western bridge, the bridge or the Western bridge, for example, you apply at the top and at the bottom one, like this one, okay. And then of course you can have the amplifier, all right, if you want. So when you apply it, that means there are two changes, two active strain gauge there. So that means the formula will be, there will be a constant A equal to KB. I really like to to write it like this one. Okay, so formula number 8. In order to find the delta V full, I put it full here, is equal to 2, right? You time with delta V half. Okay, so in order to find the delta V full, put like this one. This is your western bridge. This is your western bridge. Okay, delta V. Okay, right now you have utilized all of this bridge. For example, you apply it. Okay, this one active. This one will be dummy. Okay, and this one is active, and this one is dummy. Okay, so you have utilized all, right? So I put it is here is R4, R2, R1, R3. So this one we will call it delta V full. Okay, can you get it? So in order to get delta V full is equal to 2 times delta V half. So you need to do the formula number 7 first. Delta V half equal to delta R over R divided by 4 times with V. Okay, to get it. Right, there. So the last example, let's look, where is it? Example. Okay, like this one. An axial load is applied to a connector. The chain in strain is measured by applying 4 strain gauge as shown in figure below. 2 strain gauge are used for strain measurement. Okay, that means 2 active strain gauge. So that means you have applied, you have utilized all the bridge. So that means full bridge. So while the other is just 2 dummy strain gauge for temperature compensation. If the maximum force applied is 400 Newton, gauge factor equal to GF 2.2 and modulus Young equal to 69 giga pascal and current flow is 25 milliamp. Determine the maximum output of the measure. Okay, the resistor gauge 120. Okay, so what you can do is, yep, I very like to use this formula. Okay, right. So right now, example, so maybe I can delete all this one first. Okay, example 5.4. Okay, so this one is like your load cell, right? If you look at carefully, so this is like your load cell. So this is your object. You push there. It's like your load cell. It's not bending load cell. So formula for the load cell, what we have delta R over R is GF EAB you time with the force P. Okay. So right now, what can you got it here is like this one, P GF over EAB. We got it delta R over R, and then after that you can get it delta V half, and then after that you can get it delta V full. Okay, done. Right? So delta V over half is equal to V over 4, right? Based on the formula. This one, the formula for delta V over V, you can get it delta R over R divided with 4. Done. Oops, sorry. And then from this one, you can get it delta V full is equal to 2 delta V. Done. Okay. All right. So first, you need to find this one first. What you can get it is delta R over R equal to GF. GF is give you 2.2. E modulus yang equal to 69 times giga. Giga is 10 power of minus 9, right? Betul Giga. Betul. Okay. Then A that's mean from this area, so you going to get it, the area is you going to get it, this one, right? The area yang nampak dia macam ni. Kalau this is your road, okay, so the area is this one. So this one, what is it, 1 cm, and the another one is 1 mm. Then this one 0.01, 0.001. Okay, done. Then you apply the force is equal to 400 Newton. Done. Then you already got it. The answer is 1.27 times 10 power of minus 3. Okay, so this one you got it, delta R over R. Alright, so next is to use this formula. We already got a delta R over R. So in order to use the formula, however, the question don't give you the delta V, but it gives you the current flow to the resistor. Okay, so if we draw again this Western bridge, okay, now this is your V. So we look at the question again. Okay, the current flow is 25 milliamp. Determine the maximum. Okay, so this load cell can be measured. The resistor gauge are 120 ohm. So all is 120 ohm, 120 ohm, 120 ohm, 120 ohm. That means the current flow to this one is 25 milliamp. Alright, so we can find the current for this one. It is like when you close this one, right? So it is like if you don't have all this one. Yep. Okay, so V equal to I 100 plus 120 ohm. Okay, so V is 25 milli. So you have time with 240 ohm. Then you will got the answer for V. Okay. Right. So the answer is 6 volt. This one is for the V. So we can apply to this one. Okay. Now you can get it delta V over 6. Delta R over R is 1.27 times 10 power of 3 divided with 4. Then from this one, you can get it is delta V. Then from this one, you can get it the delta V full. That means 2 just time with delta V. Then you can get the answer. Okay, so it's already there. It's already on the slide. Okay, so I think you can look at that carefully. Okay, so you only you can use the formula delta R over R divided with 4 plus 2 times delta R over R, but I don't like to use this long formula, so we just use the simple one, delta R over R divided with 4. Because 2 times delta R over R will give you very small value. Okay? Alright, good. Done. Okay. Boleh kot. Simple lah, I think. Quite simple. This is the relationship. Okay. it's a very important to come out with this relation. Okay, so that it make you clear. So you can find from this one, you can find this one, and this one you can find this one, from this one you can find this one. Okay. Again, do you have any question? Tak ada lah kan? Okay. No. Alright. Clear. Clear. Let's proceed. Okay. Example 15.5. Yup. The same example with the 15.3, except this example is use the bending load cell. Okay. So how can we know it's bending load cell? Is because you fix this one and then you price it this one. Okay. So in this case, I think quite simple. So you just need to know the formula for bending load cell. So we can draw it again. The formula for bending load cell is equal to 6x you time with your GF and then divided with E A B squared you time with your P. So the relationship is quite important. P, then this formula GF E A B squared, you can get it delta R over R, and then this one you can get it V over 4, you can get it what is it, delta V half, and then this one you apply with 2, you can get it delta V full. Okay, but however in this case it gives you the output voltage or the bridge is 20 millivolt. So this one the output is 20 millivolt. So you need to find the inverse it, right? Half, and then delta R, because you want to find what is the force applied. So and then you need to find this one. Okay, all right. So 20 millivolt. So this case you got it is 10 millivolt. Done. And then this one you can get it delta R over R here. V is give it to you 9 volt. Yeah, you can get it. Okay. Alright, so delta R you can get it 10 volt, you can get it here, delta R over R. Okay, 10 millivolt done, you can get it. You got it 4.4 times 10 power of 3. Okay, look at here, right? Delta V half is 10 millivolt divided with 9. You time with 4, you got it 4.4 times 10 power of minus 3. Done. And this one, you can get it the force applied by having this formula. All right. However, you need to be careful. You need to look at back. So the X, that's mean your L. The X, that's mean your L. Done. And then the AB, this one, the AB, you need to find what is it. The X, yeah, it gives you 50 milliamp. Yeah, for X, AB is 10 milliamp, B is 1 mm. Yep, you can get it. Area done. Modulus Young, he give it to you, right? Or not? Modulus Young. Ada bagi tak modulus Young? Where is the modulus Young? Yeah, 206 there. Okay, 206 modulus Young is 206. Done. Okay, he give it to you. Done. 206 times 10 power of minus 9. Done. GF is already give it to you. X is give it to you. Then you can get the P. Okay. Right. So the more important thing, you need to understand the relationship between all this one. So this one bending load cell, you apply it to the western bridge, and then from the western bridge you will get it, the final one we call it a delta V full. Okay, right. So if you only use it, whether load cell or bending load cell, and you use it for measure only the half or the top one of the object, for example, and then you only find only the delta V half, only this one. Okay, right. Done. So this is the summarize of the formula involved in this chapter. Okay, done. Okay, we have finished. Do you have any question? Ada apa-apa soalan? No? Right? No question? Okay. Hey, where is the... Alright. Okay. Okay. Alright. For your exam, right? Okay. This is the topic. This is the topic. Okay. That will be asked for the exam. Okay. This is the topic. So intro, yep. Yeah, you need to look at back. So what is the characteristic, performance, and so on, what the error, and so on. Okay, and then capacity transducer. Okay, will be asked. Thermistor, RTD, and thermoelectric. Okay, of course, all of these sensor will come with the amplifier and accelerometer. Okay, and the last one is the strain gauge. Strain gauge, of course, will be combined with the Western bridge. Okay, we cannot avoid it. Right. So this is the topic that have not been asked for the test. Okay. Now, do you have any question? Ada apa-apa soalan? Ada apa-apa soalan nak tanya? Okay. Oh, sorry, saya tak nampak pula soalannya. No question. Okay. Soalannya no question, right? Okay. Alright. If you look at all of this slide, right, there is one chapter that I'm not cover is a photoelectric transducer. Yep, because this topic is actually not be asked for the exam and so on. I think this one is already covered in other subject like mechatronic subject. Okay, you can read by yourself lah, right? So it's just for your knowledge, good for your knowledge. Okay, I'll not cover this topic. Alright, and last one, nope. And okay, if you don't have any question, so let me ask you, do you want any assignment? Why, Nura Amira? Why? Doctor, up to you. Oh, no, haha. Oh, ini Fazli ini terus ada. Okay. Alright, okay. No more assignment for this subject. So please make sure you just submit the assignment one that I have mentioned you last time ago. Okay. So if you submit that one, you can get full mark for that assignment. Okay. The assignment will give you 10 mark, right? Already submit long time ago. Good. That is in my class, right? No assignment. Okay, so I think that's it. Next week we don't have class, so I hope that you can score, okay, among with your friend, okay, make a group WhatsApp only for the exam, okay, and then I hope that you will score the exam, right? For the exam, will be two type of question, I think, all right, because two set of question. So just what you have done on test one, okay, all right. And the guideline, I will send you later. So the first one, I think you need to submit the what we call it, what is the form, right? So that's mean that you already want to enroll their exam. Okay. Alright. So I think that's it for our class for this subject. Okay. If you have any question, you can WhatsApp me directly. Okay. Alright. Thank you, Siti. So next year you will go for second semester, right? Okay. Okay. Good. Thank you. See you again. Bye bye. Assalamualaikum and good morning.